right, so we're in section 8.1, which I already introduced, and this is all about solving quadratic equations. The whole goal in solving quadratic equations is to figure out where the quadratic equation, where the parabola crosses the x-axis. We already went through factoring. Method 1, solve it through factoring, which requires you to put everything in standard form first, which is like ax squared plus bx plus c equals 0. Factor it, separate the different factors, set them equal to 0, solve, and those answers will be where it crosses the x-axis. And you can always double check your work by, when you have it in standard form, put that quadratic equation into the y equals screen of Desmos or your calculator to verify that it does indeed cross the x-axis at those locations. The second method, though, that we have to learn is solving using the square root method. So this method is going to be a little bit different because if you were to try to factor this using the factoring method, like let's say I didn't give you the direction, I just said solve the quadratic equation. Like if I was to try to factor this first one, I would put it in standard form by subtracting 15 from both sides. I would get 3x squared minus 15 equals 0, and then I would factor it. This would be like a greatest common factor. I would take out 3, I would get x squared minus 5 equals 0, and then I would set these separately equal to 0, but the 3 wouldn't really do anything, so I would have to just take x squared minus 5, set that equal to 0, and then solve that. Which this cannot be factored any further or anything like that. So if I was to try to do this, I actually would be still using the square root method, which is isolate the thing that's being squared, which in this case is x squared. So move the 5 to the other side. When you have the thing being squared, x squared usually, then what you would do is cancel that out by square rooting it. So you would square root here, and you would get that x is equal to, now here's the difference between previous things and now. When we square root this, we're going to get two answers, plus and minus the square root of 5. So if we were to try to check our work here with Desmos, which I can just try and quickly pull up. So if we were to check this with Desmos with the graphing calculator, we would have to put it in as y equals, and then it would be 3x squared, and then minus 15, because it has to be in standard form in order for us to see that. This here, negative 2.23, blah, 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 blah. If I was to see what that calculation would actually be, if I typed it into my calculator, this is negative square root of 5. So I have my calculator right now in front of me. I just typed it in, and it's negative 2.236067977, whatever. So that's what that number represents. And then this is the positive version of it, positive square root of 5. So you can continue to still use this to check your work, but these ones aren't going to work out as nice because usually when we square root things, they're not going to be perfect unless they were perfect squares. Now, we didn't have to necessarily do it that way. If you want to always try to factor first, that's fine. But if it specifically says solve by doing the square root method, then what you would do is basically step 1, isolate the thing that's being squared. So I would divide both sides by 3 in this case, technically. I would get x squared equals 5. And then I would take the square root from here, and I would get that it crosses the x-axis at positive and negative square root of 5, which you can write out like this. You can also write out like this as well. All right, for the next one, really, if I looked at this and I saw 3x minus 6 all being squared minus 8 equals 0, it's not in standard form. Even though it says equal to 0, standard form to factor something has to be like this. And because it's not like this, and I would have to multiply 3x minus 6 times another 3x minus 6, then subtract 8, and then see if it could possibly be factored, I'm automatically like, no, is there another way? And there is. It's the square root method. So if you see something being squared, what you want to do is isolate that thing. So I'm going to add 8 to both sides, and I get 3x minus 6 squared equals 8. And then I would go ahead and square root this to cancel out the squared. And when I square root something being squared, I'm just left with the 3x minus 6, so that's good. But then for the other side, I would have to simplify the square root of 8, so just so that it's a little bit easier. So we would have to, and also realize that it's going to be positive and negative when I do that. So 4 times 2 is 8. The square root of 4 is 2. So this would be plus or minus 2 root 2. And then I have to solve for x. So to solve for x, I would add 6 to both sides. I would get 3x equals plus or minus 2 root 2 plus 6. And then I would divide everything by 3. So when I do that, I would get plus or minus 2 root 2 over 3 plus 6 over 3 is just 2. So that means we have 2 separate answers. This is going to cross the x-axis at positive 2 root 2 over 3 plus 2. That's one answer. And negative 2 root 2 over 3 plus 2. That's our other answer. You can leave it right like this, though, if you would prefer, but technically that is what it means over here, the plus or minus, but you can leave it like this if you would rather. And then part C, same idea. We're going to add 10 to both sides to isolate this. X minus 2 squared equals 10. Let's undo the square by taking the square root. Now here's the new thing. When we square root something, we have to include this plus or minus at this point. The square root of 10 is going to stay the square root of 10. I can't simplify that. I would add 2 to both sides, and I would get x equals plus or minus the square root of 10 plus 2. You can leave your answer like that, or if you would rather write it out as your 2 answers, it would be the square root of 10 plus 2 as one answer, and negative square root of 10 plus 2 is the other answer to where this crosses the x-axis. If you want to press pause and try the checkpoint questions, and then to go over the checkpoint questions, number 1 works out nicely when I add 121. 16z squared equals 121, and divide by 16. I can take the square root of 121 over 16, so I get z equals plus or minus 11 fourths as my final answer, which means my 2 answers would be it crosses the x-axis at 11 fourths and negative 11 fourths. Number 2, I would multiply both sides by 6 first. That gives me x squared equals 144. This one's going to work out nicely. Plus or minus 12, meaning it crosses the x-axis at positive 12 and negative 12. Now this third checkpoint should actually have a squared here. That was a mistake. I meant to say that. Sorry. If you weren't sure how to go about that, put the squared now and pause and try it. But here's how you would do it. Add 108 to both sides. We have 9m minus 2 squared equals 108. We would then square root this. 9m minus 2 is going to equal plus or minus, let's simplify this at the same time, 36 times 3 is 108. So this is going to be plus or minus 6 root 3. And then my goal is to solve for m. So plus 2. 9m equals plus or minus 6 square root of 3 plus 2. Divide by 9. And simplify. So 6 square root of 3 over 9, I can just divide 6 and 9 by 3, making it 2 root 3 over 3. But I can't do anything with the 2/9. So this crosses the x-axis at 2 spots. At positive 2 root 3 over 3 plus 2/9 is one spot. And then also at negative 2 root 3 over 3 plus 2/9 is the other spot.